Hello, and welcome to the network. Today we're going to go over some subnetting. We're going to talk about what a subnet mask is, different ways to represent it, prefix length versus dotted decimal notation. We're going to talk about network IDs. We're going to talk about broadcast IPs. And we're also going to talk about how to get the number of hosts or available IP addresses within a network from the subnet mask. We're also going to talk about how to determine the number of networks in a given larger network. Let's get started. Okay, we're going to talk about subnetting right now. So a subnet mask is used to define the boundaries of a network. It's used to define where the network ID is going to be and where the broadcast IP is going to be, and between there is where any IP address can live. So it really is critical in defining networks. And you can write it in a couple different ways. One way is with a prefix length or dotted decimal, just like an IP address. So just like an IP address, it has 32 bits total. 32 bits. 4 octets, right? An octet means 8, a set of 8 bits. 4 of them, just like an IP address. So if we take a prefix length of 22, so we say /22, right? What is that? Well, it literally means there are 22 subnet bits in that subnet mask. Subnet bits always start from the left. Always. And there will be 22 of them. And subnet bits are always going to be 1. It will always be set to 1. So there's going to be 22 of those. We're going to say 1, 2, 3, 4, 5, 6, 7, 8, dot 1, 2, 3, 4, 5, 6, 7, 8, dot. That's 16. 17, 18, 19, 20, 21, 22. That's 6, 7, 8, and then 8 zeros. What this shows us, to the left, there are 22 bits set to 1. Those are called mask bits, they're called subnet bits, they're called subnet, mask, bits, whatever. And to the right are the host bits. That's where the actual individual IP addresses are going to come out of the network. So we can actually write this in dotted decimal notation. We can convert this really easily just doing the binary math. We know that 8 ones is actually 255.255. And now we've got dot. Okay, so now how do we do this one? Standard binary to decimal conversion. So this is 128. 128 plus 64 is 192. 192 plus 32 is 224. 224 plus 16 is 240. 240 plus 8 is 248. 248 plus 4 is 252, so that is 252. And this is dot 0. So this would be the dotted decimal notation of a /22. Now it's important to note, since we start from the left, what does that actually mean? It means there are only certain decimal numbers that can actually be in a subnet mask. You pretty much saw me go through most of them right here. So I'll show you. Since we've got a dot 1, if we figure all the rest of those are zeros at the end of that, what is that? Well, that's going to be 128. Well, if we have dot 1, 1, it's 128 plus 64, which is 192. If we have 1, 1, 1, right? 128 plus 64 plus 32 is 224. 224 plus 16 is 240. 240 plus 8 is 248. 248 plus 4 is 252. 252 plus 2 is 254. Plus 1, and now we've got all 8 of our bits, 255. These values are the only values that a subnet in decimal notation can have as one of the octets. That's it. And as I said, everything to the right is host bits, and we'll talk about what you can do with those moving forward when we talk about network ID, broadcast IP, the number of hosts, and the number of networks in a given larger network. Okay, now we're going to take a random IP address I'm just going to pick out of my head here with a subnet mask, and we're going to figure out the network ID, the broadcast IP, and the number of hosts available within that network. I'm just going to pick something out of my head. We're going to say, I don't know, let's just pick 32.171.12/21. Okay, so that's 21, which means the subnet mask has 21 bits in it that are ones, right? So we're going to figure out what the network ID is first. So we're going to take these IP addresses. We're going to think about this for a second. We're going to say /21. Well, what does that actually mean? It means there's 21 subnet bits that are set to 1. So we're going to just draw that out really quickly. We're just going to say 1, 2, 3, 4, 5, 6, 7, 8 dot 1, 2, 3, 4, 5, 6, 7, 8. That's 16. 17, 18, 19, 20, 21, 22, 23, 24 dot 0, 0, 0, 0, 0, 0, 0, 0, right? So this is actually the subnet mask written out using binary. So we're going to take this number here and we're going to realize that, oh, you know what? This is fascinating. Okay, this is where the subnet bits meet the host bits. Remember, everything to the left of this last one right here, right? Everything to the left here is subnets. Everything to the right is host. So in order to determine the network ID, we are actually going to set every single host bit to 0. So we want every host bit. This means that every host bit will be set to 0. So because the subnet bits meet the mask bits here, that's the important part. We can carry down the 32.171, and this is going to be the one that we change, right? So when we take 94 and convert it to binary, we know we can't fit a 128 in there. We can fit a 64 in there. 64 plus 32, nope, that doesn't work. That's going to give us 96. But 64 plus 16, right, gives us 80. Plus 8 is 88. Plus 4 is 92. Plus 2 is 94. So that is 94 converted to binary. So now that we've done that, we say to ourselves, okay, we want every host bit to be 0 to get the network ID. So what we're going to do is we're going to write this number out right here with 0, 0, 0, because this is the host bits, right? This right here is the host bits. Right of that, right? And we're going to change all of these. Are going to stay the same. So 1, 1, 0, 1, 0 right here, right? So what does that mean? Well, let's figure that out. 64 plus 16, right, is going to be 80 plus 8. Guess what? Got 88. And this is all zeros because all the host bits have to stay 0. So the answer for the network ID 32.171.88 .0 slash 21. That slash 21 is important. Put that in there. To determine the broadcast IP here, right, this is a broadcast IP address. We need to set all the host bits to 1 to get the broadcast. Okay? We're basically going to take this number here, which is 94 in binary that we'd done earlier. I'm going to write it out here again, because again, this is the only octet that is actually going to really be mostly manipulated, right? And we know all the host bits have to be set to 1, so instead of it being 0, like in this case, we know this is going to be 255, because 8 ones is 255. We know that in binary. So the part we need to convert, again, are the host bits. Well, if we look up to the top here, right, this is where the subnet bits meet the host bits, right here, right here. So these bits all have to be 0. I'm sorry, in this case 1, right? We're doing broadcast. So we're going to set them to 1. 1, 1, 1. It's going to be 255, 1, 1, 0, 1, 0. So now this number we have to figure out. Now we know for a fact, right? All we did was change this 1. This is actually going to be 95. Right? Because 64 plus 16 is 80, plus 8, 88, plus 4 is 92, plus 2 is 94, plus 1 is 95. Got 255. We just bring these numbers down because they are completely masked out. This, the broadcast IP. Boom. And you don't need the mask. Why? Because this is an IP address. This is not meant to signify a network. You do not need to put that on there necessarily. You could, but you don't really need it. An IP address. This is a network, so it's important. This is an IP address. Granted, this is also an IP address, but you're specifying a broadcast IP versus a network identification. Now, what you'll get from this is that what this means is anything in between 32.171.88.0 and 32.171.95.255 is an available IP address on this network, right? And we'll check into how to figure that out next. Taking this IP address here and this network, we're going to figure out number of available host IPs or addresses, right? How do we do that? We take the slash 21, and what we say is the formula is 2 to the x minus 2, where x equals the number of host bits. Well, we've said before that this slash 21 means there are 21 subnet bits, 21 mask bits. There are a total of 32 bits in an IP address. So 32 minus 21 should give us the number that we need. 11. There are 11 host bits. So we're going to take that and put it in here. 2 to the 11th minus 2 equals what? So 2 to the 11th, obviously you can go on a calculator and figure that out. You can kind of do it in your head though. Once you've done binary enough, you can start to do these things in your head. You can literally just go 2, 4, 8, 16, 32, 64, 128, 256, 512, 1024, 2048. 2048 minus 2 equals 2046. There are 2046 available IP addresses in a /21. The answer. What if we were asked how many /21s are in a /16? So how many /21s can we fit into a /16? In order to do that, it's very simple. There's a couple ways you can do it. You can kind of rattle it out in your head, and I'll draw a little picture of how you can rattle it out in your head. Or you can actually do the math, and even that math you can kind of do in your head, depending on how large, obviously, the binary number is. So one way to look at this is if you take a /16, a /17, there are two /17s in a /16. There's actually two /18s in a 17, which actually means, right, that you can say there's 4 /18s in a 16, which means there are 8 /19s in a 16, which means there are 16 /20s in a /16, which means there are 32 /21s in a /16. That is going to be our answer. Another way to figure that out is by saying the formula is 2 to the x, where x equals the smaller subnet mask, which is actually the larger number, 21, minus /16. So 21 minus 16 equals 5. So this is going to be 2 to the 5th. 2 to the 5th, again, you could do it on a calculator, or you could do it in your head. 2, 4, 8, 16, 32. Now don't let it confuse you that I said this is the smaller mask. Yes, the more subnet bits you have, it's actually a smaller network. The more subnet bits, you're crunching down the amount of host bits that are left. Smaller network. The /21 would be a smaller network than a /16. There you go.